Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. This is actually the last problem from exam MLC in spring 2017 offering of it that I'm posting here. All the other problems from that exam have their solutions posted in this channel. So this is the last one. I'm recording this on October 26th, Thursday, just a day before exam MLC for fall 2017. So, well, best of luck to those of you who are taking the exam. This is a difficult exam, but it's really worth your while to study hard for it. Here's the story of this problem. Barry and Steve are both age 61. Barry has just purchased a whole life insurance policy. Steve purchased a whole life insurance policy 1 year ago. Both Barry and Steve are subject to the following 3-year select and ultimate table. So you can see that the effect of selection wears off after 3 years. And you have the size of the population subject to selection. And all this data will be used in the solution. The force of mortality is constant over each year of age. Calculate the difference in the probability of survival to age 64.5 between Barry and Steve. So under constant force of mortality, and let's write mu for that constant force, over the year from age x to x plus 1, the probability of survival is e to the minus mu over 1 year, and the probability of survival over half a year is the square root of e to the minus mu, or e to the minus mu to the 0.5, or e to the minus 0.5 times mu, which is the square root of the probability of survival over the whole year. Barry has just purchased the policy, so he is a part of a select population as of now, age 61. His probability of survival to age 64.5 is the probability of survival of 1 year for population age 61 in brackets, so selected now. Then 1 year for population at age 61 in brackets plus 1, then 61 in brackets plus 2, and then at age 63, half a year survival for no longer selected population at age 63 for half a year. But the probability of survival for half a year is the square root of the probability of survival for the whole year. And now we read these probabilities of survival from the table as the ratio of the population at the end of the year to the beginning of the year, and we plug in all of these into substitute them the ratios of the size of the population at the end of the year to the beginning of the year in all 4 cases from the table. And you can see a lot cancels out, but we are left with 5737 over 8654 times the square root of 4016 over 5737, and approximately the ratio, all this probability of survival really. But the first ratio times the square root of the second ratio ends up being 0.5546543. Now Steve purchased the policy 1 year ago, so he is now age 60 in brackets plus 1, and his probability of survival to age 64.5 is the population selected at age 60 plus 1, probability of survival for 1 year, 60 in brackets plus 2, survival for 1 year, 63, survival for 1 year, because at 63 the selection effect wears off, and then 64 for half a year, which is the square root of the probability of survival for 1 year at age 64. And again, we just plug in all of these probabilities of survival for 1 year are ratios of the population size at the end of the year to the beginning of the year. And in several of these you can see that the numbers cancel out, so we just left with 5737 over 9600 times the square root of 4016 over 5737, and that's approximately 0.4999977. And the difference of the two values is approximately 0.0546556, or 0.055, answer C. Please remember this is copyrighted material. This problem comes from Society of Actuaries examination, so the problem belongs to Society of Actuaries and is reproduced with permission. The solution is mine. Well, good luck in your studying and good luck on the test, especially those who are taking exam MLC tomorrow. All the best.